distinguished guests, Mr. Bamba, members of space, astronomers, professionals and amateurs, students, ladies and gentlemen. First of all, let me thank Space for inviting me here for this conference and also giving me an opportunity to tell you about some of the work that we are doing in India. So this my coming here happened as actually a chance meeting when we organized a brainstorming session to prepare for the transit of Venus. So we organized such a meeting about a month ago in the Indian Institute of Astrophysics. And in the break, the tea break afterwards, I met Mr. Bamba, and we had a long chat. And as a result of that, he invited me to come and talk to you all, and I'm very happy to do that. I'd also like to, before I begin, I'd like to record and join what Mr. Rotella said and record my appreciation for the activities that are being done by Space. This is very commendable. You know, Mr. Rotella also mentioned that apart from the fact that there is that to make people aware about solar eclipses, of course, that's in itself a commendable activity. But also what is commendable, I think, in the Indian context is the social aspect, to be able to create as part of the building up of a scientific temper and to dispel non-scientific views that are held by a large number of people. I'm actually surprised and shocked that in a country like Bangalore, in a place like Bangalore, which is the high-tech capital of India, there is so much superstition associated with solar eclipses. And I think that this type of effort that is being done by organizations like Space and other organizations truly help to dispel these kind of non-scientific types of views. So having said that, let me now begin. I should also like to make a confession, because I see so many experts sitting here. I am not a solar eclipse professional. I do agree with the first part of what the meeting is about. That is, I'm an eclipse chaser, but I'm not a solar eclipse professional. But I would like to tell you at least about some of the eclipse activities that have been going on in India. So the birth of modern solar astronomy in India actually goes back to what we already heard earlier from Mr. Rotella about the 1868 solar eclipse. This picture is actually a painting of the Kodaikanal Observatory. It was by an unknown artist. I don't know who it was, but it is a view which you will not see today, because there's a very dense forest of trees, of the pine trees, which blocks that view which you see out there. So the total solar eclipses. Total solar eclipses have been observed in India for a long time. We already heard from Mr. Rotella. He mentioned about the Mahabharata and a total solar eclipse taking place at that time. But turning to more recent times, the total solar eclipse of 1868, August 18th, with a totality of 6 minutes 47 seconds, which was observed from Guntur and Masulipattnam, by the Madras Observatory astronomers. The Madras Observatory is actually the forerunner of my organization. It started off in 1796 as the Madras Observatory. Later on, it shifted to Kodaikanal, and in 1971, the Indian Institute of Astrophysics was formed. Basically, it was part of the Kodaikanal Observatory. So this was when you also heard that the helium was discovered. It was a line which was very close to the sodium D2 line. And the corona was photographed during the annular eclipse in 1872 by the director of the Madras Observatory at that time, an Englishman called Norman Pogson, who observed the chromospheric flash spectrum. And this is the first observation of such an event during an annular eclipse. So this picture actually shows you Norman Pogson. He was very prolific in the kind of work he did. Unfortunately, he didn't publish enough, but he certainly did a lot of work. He studied minor planets, He named his daughters after minor planets. His name is also associated with the Pox and magnitude scale for those who are professional astronomers. And this is a drawing. The bottom is actually a hand drawing. The location of the helium line in the solar spectrum. Okay, why do we observe solar eclipses? Of course, for me, I think it's just the beauty of the event. It's a very spectacular event, and that itself is a sufficiently strong reason to observe a solar eclipse. I mean, most people observe it for that reason. People travel far and wide to observe solar eclipses. But there are also other reasons. They provide a natural laboratory to study the solar corona. And I'm not going to go into the technical things, but this actually, the main problem of studying the corona is the scattered light. And the solar eclipse is the cleanest way to study the corona because the scattered light is, there is no other way to obtain such little scattered light as you do when you observe it during the time of an eclipse. Of course, eclipses are very rare events. I mean, they're not that frequent, so you need other ways to do it. So you do it through an instrument called coronagraph, which artificially occults the disk of the sun. But there is still a problem because you can never really cut down the scattered light sufficiently. At least you cannot match it at the time of an eclipse. So this is one of the reasons why people continue. I mean, one of the questions which I'm often asked is that, if you observed an eclipse a couple of times, why do you keep on going there again and again? And even I tell you, my management asked me this question. It's very expensive to go to eclipses. You've done it once or twice, and that's it, Why? And you have to tell them that, first of all, they are actually, with technology, you've been able to do observations which were just not possible earlier. And you need to reinforce these by keep on doing them again and again. And the list of problems that you can do is not been solved. I mean, we've taken up some problems, but there are a large number of problems. So it's important to continue to study eclipses. I'll just tell you, I'm going to split our record of the solar eclipse expeditions from India into two phases. One from 1970 to 2003, and then more recent ones after that. So the eclipses that, in fact, these are some of the notable eclipses that in which Indian expeditions participated, starting from the 7th March 1970, which was in Mexico, and then there was the 16th February 1980 eclipse, which for me is a very historic event because that was 1 week before I got married. Actually, that was the day I got engaged. And unfortunately, I could not go to this. I'll show you some pictures. I couldn't actually go to these places because I was meeting my fiancée in Hyderabad, where we did actually see the eclipse together in Hyderabad, but I just photographed it and I just saw it. Whereas this was where very professional teams were doing experiments on the eclipse. And then we sent teams out to Indonesia, Hawaii. It's great to be in the eclipse business. Look at the places you can travel to. Waikoloa, Hawaii, Chile. Then in 1995, there was the eclipse at Neem Kathana, and it was seen in many places. Then 98 to Venezuela, then Isfahan, Iran, and then Maitri, Antarctica. And I'll show you some of the pictures that we have of these. So let's start off with the eclipse of February 16, 1980, which was where we set up camps at two places, both in Karnataka, which is not very far from Bangalore. This was an eclipse of about 2 minutes, 30 seconds. And this is Professor Bappu, who was the founder director of the Indian Institute of Astrophysics and also a real professional solar eclipse person. And they set up this huge tower basically to get a long focal length. So they did spectroscopic work and photometry, polarization. And it was really, because it was so close to our institute, we could take, we could set up this tower, we could take spectrographs, and it was really a very impressive amount of work that was done in preparation and also in terms of the kind of experiments that were done during this eclipse. This is the eclipse in Chile on November 3rd, 1994. This is at the border, actually, the northern part of Chile, at the border of Chile and Bolivia, and where this has basically been, this is basically the kind of work which we've been doing all through eclipses, basically doing spectroscopy in the green and red lines. I'll say a little bit more about that later. Now, this is an eclipse in which I participated. This is my second eclipse, actually. After 1980, this was the second opportunity I had. And this was a place called Neem Ka Thana in Rajasthan. It's a very short eclipse at this place, only 51 seconds. I actually just went as an onlooker to just see the eclipse. But it was also, I remember, it was also just the day that was Diwali, you know, that night before that was Diwali. So it was, we were up the whole night listening to firecrackers, and we were all very excited. And then in the morning, they put me on TV to, as I said, guide the Indian population through what was going on. And I was absolutely on the spot because, as I said, I'm not a professional solar eclipse astronomer, but nevertheless, but I remember it's a very memorable moment. Another place where we had an expedition was in Kalpi in UP. There the totality was a little bit longer, 59 seconds. Then this is the eclipse in which a small team of about 4 persons went to Venezuela to observe the eclipse. And this is another eclipse which I remember there was a tremendous amount of preparation because this was in Antarctica. As you know, India has a camp at Maitri. So we decided to use Maitri as the venue for studying the eclipse. And it was actually just at the horizon, just above the horizon. And I remember the preparations that went in because to get to Maitri is a very elaborate affair because the Indian team first went to Johannesburg. From Johannesburg, an Air Force plane took them all the way to Maitri. Then they had to acclimatize. I mean, they had to get used to that area. And finally, you know, you can see it's snowing. You know, the conditions there are not ideal, really, for carrying out these kind of experiments with power problems and all these things. Nevertheless, they did manage to. I don't think they were able to really do, come out with many research kind of type of results, but they were able to take some photographs. And anyway, I think it was, from the people who went there, they told me it was absolutely a very lasting impression that they have of this. Now, this is, in recent years, I've been chasing eclipses much more regularly than I did in the period that I just talked about. And talking about this eclipse, which we observed from Turkey, from Manavgat, which is very close to Antalya, I remember taking a flight from Delhi to Istanbul on Turkish Airlines, and I saw a large number of children. This was actually the group which was being escorted by space. So there were these 60 children who went to, not to Manavgat, but they went to nearby, to another place, probably Antalya, to observe the same eclipse. This time we took more professional, we took more elaborate equipment. These are 2 14-inch Meade telescopes which we took. This is the Indian team. This is Professor Jagdev Singh, who you might have met. He's really one of the sort of fathers of modern eclipse expeditions. I'm not going to go into the details, but the idea, the experiment that we conducted here was to look for high-frequency waves in the corona. And why is it so important to study high-frequency waves? Well, the motivation for this experiment was that to understand the heating of the corona, there have been many mechanisms that have been proposed. And one of the mechanisms that has been proposed is that it could be due to waves that are generated possibly in the lower regions, which then travel upwards and then can hit the. But so far, the efforts to detect waves like in the corona have not really proved very successful and convincing, at least. So this was an experiment where we did observations both in 2 lines, in the green line, which is 5303, and the red line, which is 6374 angstroms. And This is an analysis which has been done by our friend here and his students to try to look for power at different frequencies. And they were able to, this work has been published, and they have, in fact, they did find, this was the first experiment that we did in recent years where they reported the existence of high frequency waves between 20 to 30 seconds period of that kind of periodicity. The next expedition which we went to was in China, and I remember that Jay Pasikoff isn't here, but he was also there at that. And this is, we set up camp in the Shanghai region. It's actually about 2.5 hours drive from Shanghai on a small hill, which is called Tinhuanping, and they had set up a huge area for people who wanted to do astronomy experiments. So we got a nice big space, and we set up this, you see this tent, and that's Deepankar, that's Professor Singh, and then there are some other people. And this shows you basically, this is the position where the slit was placed. So this is this shows you the slit position there. And for this, we actually ordered 2 telescopes, 40 centimeters aperture from DFM. So this was the first time we actually ordered professional equipment, which was custom made for this. We took about 1.5 tons of equipment for this expedition, which consisted of these 2 40 centimeter telescopes from DFM, as well as a spectrograph. So this was the first time that we actually took a spectrograph for an eclipse expedition, that also at a remote site. And these are just lovely pictures which show that if you process these images, this allows you to study the streamers, in the corona quite well. And the most recent eclipse that we went to was in Easter Island, Rapa Nui, is what it's called. These show you those statues out there, which those of you who've been there would know how spectacular they are. So this was an eclipse with a totality of about 4.5 minutes. And I must say that since 2006, all the eclipse expeditions that we've been to, we've been very lucky. We haven't had any clouds. When we went to China, in fact, the morning, the eclipse was around 9 o'clock or so. At 5:30 when I woke up, I saw it was raining heavily. It was completely overcast. And it remained like that till about 8 o'clock. At 8 o'clock, it started sort of getting better. And lo and behold, just before first contact, the clouds just parted. But they did come back. But at the time of totality, we actually had absolutely perfect conditions. A similar situation happened at Easter Island. This shows you actually there we also had rain, but it had cleared up several hours before, so it wasn't too bad. So this shows you what the sky looked like at that time. These are the wonderful, those soldiers you see in Easter Island. This is the Indian ambassador who was very keen to also join us, so he flew in from Santiago as well to be there for the eclipse expedition. Okay, since this is a very general crowd, I'm not going to go into details. For those of you who are interested in such things, you can just read them. I'm not going to spend too much time on them. But basically, we did, again, spectroscopy in this experiment, in this, for this eclipse. But the new element, every eclipse we've introduced a new experiment. So we've been observing the green and red lines, but this time we also decided to look at H alpha because we wanted to study the chromosphere. So this was, for the first time in our experiments, we had spectroscopic and to study the chromosphere in H alpha. So these are basically, this shows you, we had 2 spectrographs. This was for doing the emission lines, the green and red lines. This is for the H alpha. And that shows you what the sky looked like again. I'm going to skip that. Okay. I think I should also skip that. So let me just, for those of you who have sort of a technical interest, what have we achieved? And this is one of the questions which, that I told that people ask, have you really achieved anything which has contributed towards, in a fundamental way, towards our understanding of the sun? Well, I would say we are making some effort in that direction. That is, one is, as I said, that we have all our experiments have confirmed the existence of waves in the corona. The periods, we believe, are in the range between 30 and 60 seconds. All these experiments confirm this. And we have done it in two ways. First, the first experiment, which we did from Turkey, was we did it through photometry, basically, intensity. And the second independent confirmation of this result comes from spectroscopy, again, by looking at the lines and the Doppler shifts. So we have been able to confirm the existence of these waves in the corona. I'll skip that also. We also observed, but there was not really much, there was not really many scientific experiments, but just more for the beauty of it. We observed the annular eclipse of 15 January last year, and we went to Kanyakumari. We also have a radio telescope at a place called Gauribidanur, which is near Bangalore, and from there also some observations were taken. So this is a picture which actually provided to me by Mr. Pandey, who was the director of the Nehru Planetarium, which I think is a nice picture of the annular eclipse. Now, just moving away from eclipses, I just want to, in the few minutes that I have left, I want to tell you about some of the new programs that we have started on in India. One of them is we are building a coronagraph, a space coronagraph, which will be launched in about 3 years from now on Aditya 1. Many of you might have read about this in the newspapers, that the Indian Space Research Organization has approved this program. The Indian Institute of Astrophysics is the nodal agency for executing this project. So again, the objectives of the space coronagraph are related to trying to understand the detailed conditions in the corona. I'm not going to read all of them. You can see them. An important application of this study is, of course, space weather, to be able to understand coronal mass ejections and their properties. And this helps in being able to, as far as the space climate is concerned, the effect on satellites and so on. So this has also some direct benefit as well for concerning satellites, etc. And in the other program, which I'd like to talk to you about, is that we have submitted a proposal to the government of India to set up a large solar telescope of 2-meter aperture. And if this project is approved, which we are hopeful it will be, this would be the largest solar telescope in the world for several years to come, at least till the Advanced Technology Solar Telescope comes. So we hope to be able to realize this project in about 3 to 4 years, to complete it by 2016. And this shows you a place where this is the Pangong Lake in the Jammu and Kashmir area. It's at an altitude of 4,500 meters. This is a sort of an artist's impression of what the telescope would look like on the shores. These are actually places where we conduct experiments, but this is what shows you what it would look like. So this is this beautiful lake. It has a little protrusion out here, and we hope to put it there. And the idea is that a water body provides you a thermally stable environment for carrying out solar studies. I think I should probably just skip this, but this just tells you what we're trying to study. We're trying to study effects of magnetic fields, how magnetic fields on the sun are generated. We're trying to understand the properties of sunspots, the details, and we're trying to understand the properties of the different types of magnetic structures. This is an image taken from space, from the Solar Dynamics Observatory, showing you all the different types of, a range of phenomena that takes place, flares, coronal mass ejections, and so on. One of the novel features of this telescope is that in the day it will study the sun, and at night it will study the stars. So there will be no downtime. It's a 100% duty cycle. You will be using this telescope for doing both solar astronomy as well as for doing nighttime observations. I'll end on what we've been doing in terms of public outreach. And the Indian Institute of Astrophysics has been participating in a very active manner in the International Year of Astronomy. And this shows you a float which was actually, this was executed by us at the Republic Day parade of 26 January 2009. And it showcases basically the indigenous efforts in astronomy. This is the giant meter, this is a model of the giant meter radio telescope, which is functioning near Pune, which was developed in India. And the other is a model of the 2.3 meter Venubapu telescope, which is in Kavalur, out just not far from Bangalore. So this was what was accepted by the Republic Day committee, and I think it went off very well. We've also participated in another cornerstone project of the International Year of Astronomy called 100 Hours of Astronomy, in which we participated in the Hanle Chandra telescope. We have a 2-meter telescope in the Himalayas, and that participated in a program called Around the World in 80 Telescopes. So there was a live webcast which was seen by people all over the world. I don't know if anybody here saw it, but this was, from what I hear, it was seen by a very large number of people. And finally, I should also mention that we have developed a low-cost 10-centimeter telescope, which we have been distributing to schools, colleges, institutions, in fact, to anybody, as long as our stocks last. Now, anybody who wants a telescope can just go to our website and just fill in the form and order one. So we are involved in many ways, and in public outreach. I should also mention that I hope that this will also be the beginning of a collaboration between the government-funded bodies like the Indian Institute of Astrophysics and other institutions, the National Council of Science Museums, and space. And I think that the transit of Venus is one occasion where we already had discussions on what kind of things we can plan for it. So I'm very hopeful that this will lead to a very positive outcome. And I would like to once again thank you very much for your attention.